Every one of us to Math 162 class, and we have our course outline. We have the introduction, population, and sample down to week 11. And if you notice, most of these, some of the weeks, you are going to be doing the practical application of the course. So as time goes on, we'll get to do that as well. So quickly, let's move to the topic for the day, which is random variable definition. Random variable. Now, what is a random variable? A random variable is a function that associates a real number with each element in a sample space. A random variable is a function that associates a real number with each element in a sample space. Now, when we say a sample space is a place where experiments are being stored. For example, if you toss a coin has two sides, so it is represented in a sample space. You are going to have head and tail. If you toss a die has 6 sides, so it will be represented in a sample space 1, 2, 3, 4, 5, and 6. So that's what we mean by a sample space. Are you getting me? So a random variable, for example, is a function that attach a real number with each of the elements that you have in the sample space. Are you getting it? Now let's take example. Random variable example. A fair coin is tossed 3 times. Let S denote the number of times that head shows up. Write out all the possible members of the random variable. Now, if we are saying that a coin is tossed 3 times, it simply means that the total probability of this coin is going to be 2 raised to power 3. 2 raised to power 3 is going to be equals to what? 8. Are you getting me? If the coin is tossed 2 times, the total probability will be 2 raised to power 2. That's 4. If the coin is tossed 4 times, the total probability will be 2 raised to power 4. And what's 2 raised to power 4? 2 raised to power 4 is 16. Are you getting me? But in this case now, the possible values for us to get the number of times the coin is being tossed is going to be 8 good times. That's 2 raised to power 3. Now, the possibility of tossing the coin, if you toss a coin, you know a coin has a head and a tail. So if you toss it the 3 times, there is probability that when you toss it the first time, head is going to appear. When you toss it again, head will appear. When you toss it again, another head will appear. So there is that possibility. Another possibility is that you can have head, tail. Another one, you can have head, tail, head. You can have head, tail, tail. You can have tail, head, down to tail, tail, tail. So these are the 8 possibilities you can have when it comes to tossing a coin 3 times. Are you getting me? Now let's calculate. The number of heads that we have in this question is how many times did head appear? You can see that head is appearing 3 times for the first one. Head appeared 2 times for the second one. Head appeared 2 times for the third one. Head appeared 2 times for the fourth one. Head appeared once for the fifth one, sixth one. Head appeared once for the other one, and the remaining one, head also appears how many times? Once. Now let's go back to the definition of random variable. A random variable is a fair coin. When a fair coin is tossed, a random variable is a function that associates a real number with each element in a sample space. Now let's calculate the types of before the types of random variable. Before that, let's quickly deal with the example that we cited earlier, the solution to the example we cited earlier. Now, before the solution to the example, let's quickly explain types of random variable. We have 2 types of random variable. We have discrete random variable and continuous random variable. When we say something is discrete, it simply means that it is finite. When we say something is continuous, you know that it is continual in nature, right? But in mathematical sense, in random variables, one of the things that we use in recognizing discrete random variable is the summation sign. Are you getting it? But for continuous random variable, we usually use the integration sign to represent continuous random variable. Now, so a discrete random variable assume whole numbers, countable values, while continuous random variable assume all the values in a particular interval. Are you getting it? Now, probability distribution. Back to the example we cited earlier. Now let's find the random variable. Now recall that how many times do we have we have example from 3 coin tosses. The one we cited earlier, we have 0, 1, 2, 3. How many times did nothing appear at all? So if you go back to the example, you see that nothing appears one time. Okay, for let's leave that in case you are confused. How many times did one appear? You notice that one appeared 3 times. I mean head appears 3 times. Are you getting me? For the first one. The second one, there are two possible ways. Two appeared how many times? 3 times. Are you getting me? And similarly, three appears how many times? One single time. And zero appear how many times? No, zero means nothing. Nothing appear how many times? So that's one. Now you must know that every probability that you have, for every probability that you have, the sum of every probability must be equals to zero. Let me quickly take you back to the table back again. You see that we have head. X is how many? X is representing number of head now, which is 3. The other one head, 2 head. The other one 2 head again. The other one 2 head again. The other one 1 head, 1 head, 1 head. So if you count that now, that's 1 2 3 4 5 6 7, and the last one 2, which is 0. You know the last one is going to be tail. Are you getting me? The last one is tail. So tail simply means that no head appears. So that's why we have the number of times the tail appears to be equals to what? 1. So that one is 1. So we have, now if you add everything together now, 1/8 plus 3/8 plus 3/8 plus 1/8, everything is 8/8. What's 8/8? 8/8 is 1, which simply means that this is a probability. For every probability, the sum of all probability must always must be equal to what? 1. Now, having said that, properties of a discrete probability distribution. Properties. Now the first property is that a probability ranges between 0 and 1. Are you getting me? That's the first one. Another one is the sum of all probability must be equals to 1. So if you are solving a probability question and you arrive at 1.1, it simply means that you need to check your solution again, because you can never have an answer greater than 1. The maximum value that you can have for a probability question or a random variable question is 1. You can never have anything above 1. Now that's for discrete. So as you can see that for discrete now, all of them we are using a summation symbol. But when it comes to continuous random variable, for a continuous random variable, you use an integration sign with a particular area. So the total area under the curve of f of x is also equals to 1, because it is also a probability, but it must have what? A boundary. So when you see probability density function is usually the name given to continuous random variable. So if you see PDF is for continuous random variable. That's probability density function. Are you getting it? Now, moving on to some special discrete probability distribution. All of these are discrete. So Bernoulli distribution, binomial distribution, Poisson distribution, geometric distribution, hypergeometric. There are a lot of them, but these are the limited ones for your level. There are a lot of them. So the next thing is the continuous example of continuous random variable. Typically there are a lot of them as well, but the one picked for this course is normal distribution. So properties of a normal distribution. Don't forget, normal distribution is what? Is a continuous random variable. So properties, it is always curved, it has a bell shape, it is symmetry, the mean, the median, and the mode, they are the same thing. They are defined by 2 parameters. That is, it is characterized by mean and standard deviation. Are you getting it? So it also has what we call the empirical rule. It has 68%, 95%, and 99.7% if the data fall within, if the standard deviation is between 1, it is approximately 68. If it is between 2, it is 95. If it is between 3, it is 99.7. So now another property of normal distribution is that it is asymptotic. That is, the tail of the curve extends indefinitely in both directions. That is, it keeps on going. Another one is that the total area under the curve is always equals to 1. Another one, it is unimodal. It has only one mode, the peak of the bell, which is the top of the bell. That's the mode of a normal distribution. It is also a continuous distribution, which we already stated earlier. So let's take an example. Now, Assignment problem statement. Given the following probability distribution for a discrete random variable x. So as the word implies, since you are dealing with discrete and they gave us the value for x to be 2, 3, 4, 5 respectively, and their probability to be p, 2p, p over 2 and 3p, they want us to find the value of p and work out 2 less than x less than 5. That's the task. So the first task is find the value of p. The second task is find the boundary of the value of x that is between 2 and 5. Now don't forget, because we are dealing with a discrete random variable, it simply means that all of the random variable you are going to use will be having a summation sign. But assuming the question is saying a continuous random variable, you'll be using an integration sign, and which is summation of probability of x multiplied by the value of x. Are you getting me? Now if you add all of the probability of s equals to 2, s equals to 3, s equals to 4, s equals to 5, and you equate it to 1. So by equating it to 1, you add everything together, you have the value of p to be 6.5, p is equals to 1, and you make p the subject of the formula, which is 2 over 13. So that's the value of p. Are you getting it? Now part 2 says that we should find probability of s less than 5 and s greater than 2. So if you want to find s less than 5, you find s less than 5 simply means that you are going to be dealing with probability of s is equals to 3, probability of s is equals to 4, because we already said that it is less than what? 5. It is less than 5 and greater than 2. Less than 5, greater than 2. Anything that is less than 5 and greater than 2 simply means that you are dealing with only number 3 and number 4. Are you getting me? And you already have x to be equals to 3 to be 2p, and s to be equals to 4 to be 1 over 2p. Don't forget that you already found the value of p to be 2 over 13. So when you substitute that value of p to be equals to 2 over 13, you get your answer to be equals to what? 5 over 13. So approximately p is 0.1538. Are you getting it? So p is equals to 0.1538. Now you might be wondering how we come about the 0.3845. Now the 0.3845 is a normal, you can find this using, you can use this on your calculator to find the value of 0.3845, which we'll be doing in the next video. So that's all for this video. Thank you.